finishing up with the third unit today. Optimization. So typically speaking, we have a particular quantity that you're going to be interested in either maximizing or minimizing. And then generally speaking, there's going to be some auxiliary condition that also needs to be satisfied, right? So your constraint, just like with related rates. First, introduce all of your variables, just like we did with related rates, and draw a figure if necessary. You need to then determine what quantity are you trying to optimize. And for what range of values. Write a formula for the quantity to be optimized. This could involve more than one variable, right? So area, for instance, you have two variables, length and width. That is where your constraint comes in. Because you're going to use that constraint to reduce your equation down to a single independent variable. Once you have that formula, you need a domain. So domain could either be given to you, or it's implied based on context of the problem. Finally, locate the extremum. Right, so depends on the optimization, whether it's a maximum or a minimum you're looking for. Well, we just spent 2 days doing that. But you'll use the techniques that we've already learned to find that maximum and minimum. With one exception, I will be making use of the second derivative test with optimization instead of the first derivative test. Rectangle is inscribed in a semicircle of radius r. Find the largest possible area. It's a terrible semicircle. Yeah, it's better. Good enough government work. And we have a rectangle that is inscribed inside of it. So we can do something like this, I guess. Oh, okay, so that's actually a terrible semicircle. So let's get rid of that. first, that's just you. And then finish off the semicircle, I guess. Whatever, good enough for the work. It's not a rectangle constructed. We know what that length there is, right? We also know what that distance is. So that is the radius of the circle, capital R. We don't know the sides, so we'll just call them X and Y. Well, what's the equation of the semicircle? Right, x squared plus y squared equals r squared. So we know that y is the square root of r squared minus x squared, right? Now, notice what I'm doing now. I'm measuring x from the center of the circle. How's the area of a rectangle defined?
Like that's what?
Should be 2xy. Right? Length is twice x, so I'm saying x is only from the center, right? But we just said what y had to be. So area as a function of x. 2x times the square root r squared minus x squared. Domain. Can x be negative? Can x be 0? Well, if it's 0, you don't have a rectangle anymore. What is the largest x could possibly go to?
R.
Only out to r. Now again, r is not included because at that point you would no longer have a rectangle. We have our function to maximize. We have our domain. Now, it's time to do the math. So just like with related rates, that's the hardest part of the optimization problem, right? Is setting it up. Excuse me. Well, extreme values only occur at endpoints or critical points, right? So we have to find the critical points of A curves. That means you get to differentiate that. What's that derivative? So what rule do you have to use? Product rule. First term will be what? Twice square root of r squared minus x squared. Plus the 2x times the derivative of that square root. Well, that square root will have derivative of negative x over the square root, right? So it'll be a half r squared minus x squared to the minus 1/2 times negative 2x. Simplified to a single fraction. Common denominator. It looks like we're going to get what? 2r squared minus 4x squared. All over the square root. R squared minus x squared. Right? Oh, by the way, actually, yeah, it's fine. It works. Yes, perfect, okay. Is there anywhere that is undefined?
Going to x is plus or minus r, but that's not in the domain.
Right now, I'm not worried about that part.
Okay.
So now just set it equal to 0, right? That'll give us which is the same as r squared being equal to 2x squared, right? So what is x?
R divided square root of R divided by 4.
R over root 2, right? R is already being squared, right? Square root of r squared, r. R, because r is a radius, so it's always positive. And plus or minus. Actually, no. Do you? Oh, right, yeah. Plus or minus. R will always be positive, but X not necessarily until we look at the domain. Now you just look at which are interior. Well, none of those are interior, right? You mentioned that. It's not in the domain. And only one of these will be interior. Yeah, I'm only writing that to show why I'm not going to include the value. We only have one critical point. Here's where the second derivative test is going to come in. So I'm just going to So broadly speaking, I'm not going full details. F prime C equals 0. Positive second derivative means it's a relative min, right? Negative second derivative results in a relative max. And if it's 0, it's inconclusive. There's a corollary. To the second derivative test, which states if C is the only critical point in that interval, then the second derivative test doesn't give you relative, it gives you absolute. Oh, that's the only critical point. Second derivative test will give me the absolute extremum for area. The only question is, does that result in a min or a max? This is where I use the second derivative test to determine. Which means we need the second derivative. Oh boy. This won't be fun. How badly do I want to do this one? I don't, but we need to practice. Actually, I don't think we do. The second test went pretty well, actually, overall. But I'll do it anyway. Because why not? In this case, I'm actually going to use the simplified version. Because if I don't, I'm going to have to use quotient rule anyway. So I might as well just get it out of the way. and do it all at once. We're going to have negative 8x times that square root minus that times same thing. It's going to be what? Negative times negative x r squared minus x squared to the minus 1/2.
Can we just see if it's increasing or decreasing when we reset? Or does it not work because R is like variable?
You can, but that's going to require a bit more logic than if it was just a simple number, which is why I'm defaulting to the second derivative in this case. All over r squared minus x squared, right?
Wait, x is less than r, which it should be in its domain, then the denominator is positive, so we can only check the numerator here.
Again, it's going to require a bit more logic. I'd rather just do a more analytic argument. But you can. I won't. That's not wrong. You can set up your test intervals. Factor out that. Put that down there. Looks like what, 12x cubed minus 6xr squared? I'm going to use technology to my advantage. That would be the second derivative. So if I plug this in, what are we going to get? Should do it on another slide, like you guessed. What is square root of 2 cubed? 2 root 2?
Yeah.
That's in the denominator. 6r cubed over root 2. Minus x is r over root 2. That would be 6r cubed over root 2, which gives me 0.
I swapped x and r.
Oh. Second derivative test is going to fail. Ain't that a bitch. Unless I simplified it wrong. It's the only thing I can hope for.
It's not too late to set up test intervals.
I'm going to have to if the second derivative test is 0. I don't have a choice. Do some scratch work. Zoom that out. This is why I think the calculator. I did simplify it wrong. That is supposed to be a 4, not a 12. Don't know how I got that wrong, I don't care. Algebra is never my strong suit. Oh, I know what I did wrong. It's 3 negatives, not 2. Okay, I'm back. I know where I screwed up. Good. That means this doesn't give me 0 anymore. Yay. That's 4 over 2 root 2, which is now just 2r cubed over root 2. That will give me minus 6r cubed over root 2, all over the square root. R squared minus r squared over 2. I don't need to simplify this any further. You should be able to tell right away that's less than 0. Denominator is r squared over 2, which is positive. Or square root of r squared over 2, which is positive. Numerator is going to be negative 4r cubed over root 2. But r is positive, which means r cubed is positive. Numerator is negative, denominator is positive. That's less than 0. Yay. That means the critical point results in a max, which is what we wanted. They wanted maximum area, I believe, right? So just plug R over root 2 in for x and a of x. 2r over root 2 times the square root of r squared right, minus r squared over 2. That's r squared over 2, which is going to be what? R over root 2. Huh. That's implies it's just r squared. Measure maximum area of the inscribed rectangle.
So it's square.
It's square. Yay.
I mean, like, the original expression was pretty simple. First derivative, it was more complicated. Second derivative was even more complicated. Do you think it would be easier to do test intervals since you're only evaluating the first derivative? Derivatives usually get more complicated. What do you think?
Depends.
For this problem, would it be easier?
Again, this problem, because there was logic, you really have to understand how radius works and how everything works, because you're not really given numbers, per se.
Okay.
I always just use the second derivative test, always have for optimization. So I personally like it better than trying to set up intervals.
Okay.
But again, I don't care. You can set up intervals if you want. Because you'd be evaluating it twice. Because also, generally speaking, I use technology to find a derivative. So that's why it doesn't actually matter to me. What's the next one? Maybe I'll use, oh no, there's going to be a second derivative as well. I'll see if I can find one where the second derivative is going to be more hideous, and I'll do the test intervals. That's probably going to be number 5, actually, now that I'm looking at it. A 20-centimeter by 30-centimeter sheet. You cut equal squares of side x from the corners and fold to form an open box. Find the value of x that maximizes the volume of that revolving box. Right, and then you fold it in to get your box. Volume of X.
It's full length times width times height, which in this case is not respectively x 30 minus 2x and 20 minus 2x. Then we can FOIL it. Oh hey, it's a polynomial that's not difficult to get the second derivative of once we FOIL.
I'm going to make it a little bit easier. Factor 2 out from each one. So negative x is positive x squared times 4x. All right, so 4x cubed. Middle terms, negative x, or negative 10, minus 15, that's negative 25x, times 4x. Minus 100x squared. 10 times 15, 150, times 4,
600.
plus 600x. Domain.
All real numbers.
Can x be negative?
Oh no. I mean, it can't be larger than
So
than-
the smallest, I don't want to say smallest, the lower bound for x would be 0, right? It can't be 0, because then we're not doing anything.
let's think of the function at the bottom.
And what is the upper bound for x?
10.
10.
It'll be infinitely big.
Right, because 10 would cut this in half. There's our function, there's our domain. Now it's time to optimize. Derivative. Oh, this was easy.
12x minus 200.
Check your powers.
12x squared minus 200x. Oh, plus 600.
Is there any where that is undefined?
No.
So set it equal to 0 and solve. There is at least a 4 in common.
Yeah,
I think that's all there's going to be.
it's 200 times was the 3.
Yeah. So 200 divided by 4 would be 50, right? And that is 150. Right?
Almost like there's a common factor. But there isn't.
Yeah, that 50 doesn't have 3 common.
350 multiplied.
Oh, ain't that a bitch? That can't be factored either. Well, it can be, just not with integer coefficients. So, quadratic it is. $50 squared.
2500.
4 times 150 is 160. I'm sorry, no, 600. 600 times 3. with 2 common. And I'll just write it that way. It's not required. Oh! Which is on your interior?
Uh,
Here. Great, is it? What's 5 minus root 7? No, 5 minus root 7,
Oh,
that I think would be. Maybe we can do a quick numerical check. So root 7 will be somewhere between 2 and 3. Let's just go in the middle and say 2.5. 5 minus 2.5, 2.5. 2.5 times 5. 12.5 divided by 3. That is definitely between 0 and 12. Or 0 and 10. Plus, though, I don't think would be.
yeah, plus.
I think plus would be slightly larger than 12. Like, it should be 7.5. 7.5 times 5. 37.5. Divided by 3 is over 12.
It's slightly out of the range, it's like 13.
So I'm going to write C. Critical point would be 5/3. 5 minus root 7. V double prime.
24x minus 200. In factor of 8, I think.
No,
What?
I'm not that worried about that. The question is, 24 times C, is that larger than 200? So what do we say C is about? Two and a half times 5.
It'd be 40 times 5 minus root 7, which would be negative. Wait, 40 times 5 is, yes. Like 200 root 7 minus. So 200 minus 100.
And so it's going to be what, about 4? 4 times 24? It's less than 200. Which gives you a negative value. That results in a max. That's what we wanted, to maximize volume. Okay. And it gets even better. Does it ask for what the maximum volume is?
No,
Nope.
we have the answer.
Don't forget your units. Maximizes the volume. think I may have forgotten units. No, I didn't. No units for that one. So you're going to have to read the problem, right? Make sure you actually answer what it's asking. First one wanted the maximum area. This one didn't want maximum volume, it just wanted the value of x. Oh, fun. Find the cylinder of volume V with least surface area. And I actually need to be a little bit more specific.
Right cylinder. Are there like oval cylinders?
Right circular cylinder. If you have to take Calc 3, you'll learn what cylinders really are.
I know that you can like skew them, but you can change the base from something other than circular.
It doesn't even have to look like this.
Do you need the donut or is that the thing?
No, it's not. But if you just think of a metal plate and kind of bend it, that parabolic shape, that's a cylinder by definition.
What's the definition?
You'll learn in Calc 3. It requires 3D geometry.
Oh,
So this is just a special type of cylinder.
a cone type of cylinder.
A cone now, that's a different shape. Oh, by the way, be careful when you say cone. Cone, you're thinking it was probably a right circular cone. So it's going to have some height h, right? And some radius r. First, what is volume of the cone? I'm sorry, not cone. Cylinder.
IR squared times H.
Yes. We're going to need that. What is the surface area?
2 pi r squared plus 2 pi r h. You can factor something out of that. You can factor 2 pi r out of that.
Right, so that is the surface area. Before I factor, rewrite h in terms of r. We get what? 2v over r. Right? Volume is fixed. Right? Because they say a cylinder of volume V. So we're fixing volume. It's a constant. domain. Well, obviously R has to be positive. What is the largest value it can go to?
I don't know. That's not what we're trying to find out.
Is it 2 times the dot? No. Is it the rectangle or am I just,
Infinite.
Doesn't have a number bound. If you make R really large, that just means you're shrinking H to keep that fixed volume, right? Because it's all multiplication. So R is just strictly greater than 0. That's fine. What's S prime of R?
4 pi r plus minus 2 v of r.
At that point, I'll simplify it down to a single fraction. Where is that undefined?
When r is 0.
Yeah, so we don't care about it. For it to equal 0, 4 pi r cubed has to be 2v, right? So what's r?
Cube root of v over 2 pi. Yay.
Is that an interior point?
Yeah.
And it's the only one. Second derivative test. This is also a fairly simple second derivative to take. Right? Just go back to the unsimplified form. 4 pi plus 4v over r cubed, right? Oh, but wait a minute. Isn't C positive?
So it's positive.
Has to be positive, right? V is positive. You can't have negative volume. That doesn't make sense.
This is the minimum.
So it's positive plus positive. That is greater than 0. Results in the min. Least surface area. That's what we're looking for. We were minimizing surface area. So we just have to evaluate that. Where's I'm going to rewrite it. I think that simplifies it, right? That's going to give me, oh, that's nice. That will just give me V, right? No, 2V in the numerator. Because that would become 2 pi times 2V over 2 pi. 2V plus 2V is 4V. Over that. That would be the volume. But it said find the cylinder. So I actually didn't want that. Reading is an important skill. It said find the cylinder of least surface area, not the actual least surface area. That's annoying. Which means all of that is useless. Makes me sad.
I mean, if we have the radius of the surface area, then we would know if it's a right circular cylinder exactly what it is.
What was height given by? V over pi r squared. You get what? Pi. Two-thirds. How does that give me 2R? Oh, I see how. So that's gonna be what? One over v cubed, right? Or not v cubed, cube root of v. Work this out. And get pi to the 1/3 of the numerator. Yep, okay. R has to be that. Oh, I got it. How the hell do I get 2R out of that? So we still have to run R cubed. How does that become twice that? Yeah, I think I'm just gonna leave it like that. I'm saying I'm happy with it. Farmer has 600 meters of fencing. To enclose a rectangular field along a river. Find the dimensions of the field that maximize the area. Let's say there's the river. So there's our pen. Call that X, call that Y. Do we need any fencing along the actual river itself? No, right? Now, we do know something. Total perimeter has to be 600 meters, but what is perimeter in terms of X and Y?
2y plus x. Sorry, x plus 2.
What is the area of the fencing?
xy.
But we just want it in terms of either X or Y.
So solid for Y.
That's all for X.
Um,
Right?
and
So that wouldn't be a function of X, that'd be a function of Y. Oh, I'm sorry. Why am I dividing? Oops. That makes more sense. Is that going to be our area? Right, area of Y? For what? Well, again, Y would have to be positive, right? What is the largest value Y could be? So what is the upper bound?
300.
Well, it can't be any larger than 300. Take its derivative. Oh, that's nice. Is that equal to 0?
Y is 150.
150 meters, right? Oh, look at that. Second derivative is always negative. That critical point results in a maximum. That's what we wanted, right? To maximize area. But what is it asking for?
area of the dimensions of the rectangle.
Dimensions, right?
Yeah. So it means it has to be 300.
So 300 meters running parallel to the river, and then 150 meters perpendicular to the meter or to the river. Those are the dimensions that would maximize area. also hand out a reference sheet